Question 13. So we want to write 10 cos theta minus 3 sine theta, and we want to make it look like this. R cos theta plus alpha. Well, you should recognise this part is in the formulae book. In the formulae book it says A plus B. So let's just write this part out here. So we've got R. Now I'm going to change the order slightly just because we can make it a little bit easier. Cos theta, take away R sine alpha sine theta. Now what you can tell from here, look, if I'm just equating the coefficients of cos theta, look, I've got this bit is equal to that bit, and this bit is equal to that bit. So let's write down what we know. So we can write down, so let's write this one first. There's a reason for writing this one first. So that equals 3. And then I've got R cos alpha. That equals 10. Hey, wait a minute. What's that divided by that? That's just going to be tan. The R's are going to cancel. So I can write tan alpha equals 3 over 10. Inverse tan, 2 decimal places, and I've got 16.70 degrees. Okay, what about trying to work out what R is? Well, imagine squaring this plus the square of this. So R squared, so that's going to give me sine squared alpha plus cos squared, and that equals 3 squared plus 10 squared. 3 squared plus 10 squared. Well, that's just 1. So R squared equals this. So square root both of them, and R equals the square root of 109. So that gives us, let's just fill this in now. So we've got square root of 109, and multiply that by cos, we got theta plus, what was it, 16.70 degrees. Right, brilliant, there we go. So there's the first part of the question. Okay, right, now let's take our attention to part B. So I'm going to move that up there just to give us a little bit more room. So let's have a look at this. So the first bit says find a complete equation for the model. Well, we really need to work out what this thing is just here. Well, what do we know? And it tells us here that the initial height of the passenger above the ground is 1 meter. So therefore, when t equals 0, the height equals 1. So we can fill that in. So if I've got a height of 1, right, if t is 0, cos 0 is 1. And if t is 0, that's all going to be 0. So therefore, A equals 11. Right, fantastic. So let's write that down. So we've got h equals 11. Now I'm going to do a little trick here, because look at this part here. But it's the same really. It's in the same format as what we started with, apart from the signs. So if I were to maybe just take out minus, maybe just try and think about how I can rewrite this, it then becomes 10 cos 80t, take away, so that's now in the same format as what we needed. So I like that, but let's use what we just did here, and we can just swap this in, but instead of writing theta, we're going to put the ATT in there. So let's write that down now, and it's just going to make our lives loads easier. So we've got 11 take away, so we've got root 109, and then that's multiplied by, so we've got cos. Now instead of writing theta, I'm going to write ATT, and plus 16.70. Hence find the maximum height of the passenger above the ground. Well, the maximum height of the passenger is going to come when, if I'm taking away something here, but what's the biggest, or rather the smallest, that this could be? So I want to think when this is -1, that's the key to what we do. So if this is -1, it will reverse this sign here. So the maximum height of the passenger above the ground will be 11 plus root 109, which is, if you just pop that into your calculator, it's 21.44 meters. Now there is another page to this question, and we need to look just here. So it says find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. So remember what we're looking for. We're looking for this bit to be -1. So we know what the maximum height is. This is all we're really interested in, is when this is equal to -1. So we'll just quickly jot that bit down. So we're interested in cos ATT plus 16.70. I'm interested in when that is equal to -1. So if we inverse cos this, that will mean ATT plus 16.70 equal to 180 degrees. Remember, it's the second cycle. So if you think about cos, it has a complete cycle of 360 degrees. So the second cycle is that plus 360. So that's 540. Now if we solve this, so take away 16.7, divide by 80, that's going to give me t equals 6.54125 minutes. And the question does say to the nearest second. So how I do this is I know it's 6 minutes, and then I just take this part here. So what I do is I have this, I take away 6, and I just multiply it by 60. And then that gives me 32 seconds. And then the last bit of the question is decided to increase profits. The speed of the wheel is to be increased. Okay, so effectively it would all go by a bit quicker. So how's that going to affect our model? Well, basically, the number in front of t is going to change, isn't it? The coefficient of t, coefficient of t should increase. So, for example, it might go to 90t, it might go to 100t, okay, instead of 80t. And likewise, if you wanted to slow it down, then it would reduce that value.